Okay, the first question says, on this interpolation and extrapolation question, draw a line of best fit. So a line of best fit is you trying to fit a line through these points as best as you can see it fitting inside those points. So I'm trying to make a line that best represents this data. So something like that. So in applied, if you end up in the applied stream in grade 11, we do that quite a bit with a line of best fit, a curve of best fit. Okay, now using my line, a person who has worked 15 years is going to make how much money? So what I do is I go to 15 years, which is on the what axis? The x-axis is the years. So 15 years. And I'm going to kind of visualize that. And from there, if I go over my y-axis is the income. And on this question, this is your income times $1,000. So I can say somebody who's worked 15 years, probably going to make $48,000. Okay, that was called interpolation, and the reason it was called that is because 15 falls within where my dots are. Okay? Now, if a person makes $70,000, so this time I've been given the Y. So I'm going to go across at 70. And I hit there. So if I go straight down, so your answer might be different than my answer if your graph is a little bit different, and that's okay. So if I go straight down, I would estimate if you're going to make 70,000, it's because you have 27 years experience. Okay, and yours might be a little bit off mine, and that's fine. That was called extrapolation, and the reason is because where I landed is outside where my data was. Okay, so inside your data, if you get something, it's called interpolation, and outside is extrapolation. Okay, then we're going to analyze some graphs. Some of you, have you done this in physics? Time, distance charts and things like that? Okay, so this is speed versus time. So if the speed line is flat, it just means you're going a constant speed. If your speed line is going up, it's acceleration. I don't know if I also give you this. If your speed line curves, is your acceleration again. But what's the difference between this acceleration and this acceleration? Think about driving a car. What's this person doing on their gas pedal? They're doing constant. What's this person doing? They're trying to like rev up their engine, right? Going fast. So constant. And this one is, how do I say that? Faster and faster? Faster and faster acceleration. You're pushing the pedal in. Okay, so this is called deceleration then, right? The speed is slowing down. Okay, so what's going on this graph? So the speed is accelerating. They accelerated. Then they constant speed, aka like cruise control in a car, right? Then they decelerated. What specifically is the next portion of this graph? This is it's a constant speed of 0. So what can we say?
Stationary.
Stationary, it's stopped. There's a constant speed, but it's of 0 speed. So if you're constantly moving at 0, you're stationary. Then we accelerate again. And then we're back to cruise control, right? Constant speed. Okay. So this time it's distance versus time. So steady speed, because your distance is moving consistently. So that's a steady speed. This is that your distance is returning. You're getting closer to home. This is acceleration, because your speed is not steady. It's going up. And then this is that you're stopped, because there's no change in your distance. Okay, so here we go. So this one would be constant speed. Your distance is increasing, so you're constantly moving. Now, here we are. There's a stop, because your distance away from home is 3. It never changed, so you never went anywhere. Then here, we have a constant speed again, because our distance is changing at the same rate. Stopped. And then this is a constant speed going back home, or whatever you want to say about it. So you're traveling back to where you left.